Okay, write these 6 problems down and factor them. It's a nice little factoring review. We'll pause the video here to give you some time to do that. It should take you no more than writing time plus factoring time. I'll let's say no more than 8 minutes. Okay, for number 1, to get x squared minus 16, I know we're going to have to factor to a conjugate of x minus 4. When you have a difference of 2 squares, x squared and 4 squared with subtraction, it will always factor to the conjugate then the x plus 4, x minus 4. We can do the same logic for number 2. So that's going to be x plus 5, x minus 5. Now for 3, because it's adding, our conjugates, they're going to have an imaginary value. So that's going to be x plus 7i, x minus 7i. Okay, now for what multiplies to negative 8 that adds to negative 2, we're going to do negative 4 and positive 2. Okay, for 5, what multiplies to 15 that adds to negative 8, it's going to be negative 5 and negative 3. Then lastly for 6, you can either do box method or split the middle. Oops, sorry. So 2 times negative 3 is negative 6. And we want to multiply to a negative and add to a negative. So we're going to use 1 and negative 6. So I'm going to split the middle. Factor the greatest common factor of each piece. Regroup it. And whether you use box method or split the middle, you should get x minus 3 times 2x plus 1. Okay, so today we're going to add to our factoring knowledge. And what we have here is a thought process for factoring. We're going to pause the video if you want to write it down. And here is our thought process. Every single time you have any equation, you're going to think, is there a greatest common factor? If there is, factor it out. Then you have to think, is it a binomial, trinomial, or many terms a polynomial? The ones here in yellow, that's going to be our new factoring methods today. So if it's a binomial, maybe it was the difference of 2 squares. That was our warm-up, like the x squared minus 25. Today we're going to look at the difference of 2 cubes, but that could be sum or difference, adding or subtracting. Trinomials, we've done that a lot. And then lastly, polynomials, we're going to factor by grouping. Okay, so here's how we factor cubes. When you have the sum of cubes, we have a to the third plus b to the third. That will always factor to a plus b, a squared, ab, b squared with these signs. And here's how we're going to remember the signs. We can use the memory SOAP. It stands for same, opposite, always positive. So see how this is a plus? Same, opposite, always positive. The same thing works for difference. The a and b are going to have the same pattern. And then for your signs, the minus, so same, opposite, always positive. Down here in red, I have the first 10 perfect cubes for you. I highly recommend that you have them memorized. So we can see for A, 64x to the third plus 1. That's 4x to the third plus 1 to the third. So 4x is our A and 1 is our B. So to factor, it's going to be A, B, a squared, a times b, and b squared. Same, opposite, always positive. And now for b, 54 and 16. Oh, there's a greatest common factor. What can 54 and 16 both divide by? Okay, if you said 2, that's correct, so we can factor out a 2. And now we have the difference of cubes left in here that we have to keep factoring. So 27 is 3 cubed and 8 is 2 cubed. So we've got 3x and 2. 3x squared is 9x squared. 3x times 2 is 6x, and then 2 squared. Our signs, same, opposite, always positive. Okay, so we're going to pause the video here for you to try these 6 problems. Don't forget to look for a greatest common factor first. Okay, and these are the 6 answers you should have gotten. I'm going to do some of the harder ones, like, let's do 5. 5 has a greatest common factor of 3 that you have to factor out. Now, the 3 stays factored, and 8 is 2 to the third, so we've got x and 2, x squared, 2 times x, 2 squared, same, opposite, always positive. I'll do 6, so that has some big numbers. 1,000 is 10 to the third, and 729 is 9 to the third. So we got 10x and 9. Then we have to do 10x squared. So that's 100x squared. Then it's 9 times 10x, which is 90x, and then 9 squared. Same, opposite, always positive. You will get a lot of practice on your homework with these. Okay, so our next type of factoring is by grouping. So now we have a polynomial. We have more than 3 terms here. And here's how factoring by grouping works. It looks similar to the split the middle. When you have factoring by grouping, we're going to look at each group and see what the greatest common factor is and factor that out. Because the remaining binomials are the same, we can regroup it. We're going to do x squared minus 4 as a factor, and then x plus 1 as a factor. You always have to check to see if either of those new factors can keep factoring. X squared minus 4 is the difference of 2 squares. So we have to factor that more to x plus 2, x minus 2. Okay, we're going to pause the video here for you to try 7 through 9. Okay, for 7, this is what you should have had. I'm going to regroup it. But x squared minus 9 can factor more to x plus 3, x minus 3. Okay, I'm going to try 8. So we can factor out an x from the first group and a 5 from the second. Regroup it. Ooh, but x squared minus 1 can factor more to x plus 1, x minus 1. All right, and 9 can factor out an x squared and a negative 16. Oh, x squared minus 16 factors more. And there's our 3 answers. So now we can factor higher degrees. Notice this is a degree of 4. Even though it's a binomial, this is a degree of 4 and it's a trinomial. So here's how it works. 49 is a perfect square, and 4 is a perfect square. But is x to the 4th any term squared? Oh, it is. Isn't it x squared squared? So we can factor this as a difference of two squares, because every term is a perfect square. Okay, so now for b, what multiplies to 9 that adds to 6? I hope you said plus 3 and plus 3. But to multiply to x to the 4th and add to x squared, we're going to use x squared here. Let's multiply it back together and see if it works. I'll multiply with box method. You could always multiply your factors back together to make sure you get the original polynomial. And that's it. We did it. Okay, you tried 10 and 12. Move it up so you can see it. I'll pause the video for you to do that. Okay, for 10, did you get 5x squared plus 3 and 5x squared minus 3? And 12, x squared minus 8 and x squared minus 8. You can't factor the x squared minus 8 anymore because 8 is not a perfect square. So now you have time to start your homework. It is page 31 in your packet, 1 to 47 odd.